Hello everyone, if you are studying IGCSE Computer Science 0478 Paper 1, this video series will help you revise each topic more easily. We'll go through chapters 1 to 6, practice questions like those from the past papers. This will help you understand the types of questions you will see in the exam and how to answer them. These videos are designed to support your learning, build your confidence, and help you to get best grades you can. So let's get started and make your revision count. In this session, we'll be reviewing past paper questions on key topics such as the role of CPU, the fetch, decode, execute cycle, factor that can affect the performance of a CPU. So let's get started. Topic 17, the role of the CPU. Question 173. A student has a computer that has central processing unit, CPU. Describe the role of the CPU in computer. So number 1, to process data and execute instructions. Number 2, to run fetch, decode, execute cycle. Question 174, CPU stores all data permanently in the computer. So that's false. Question 175, which of the statement best describes the CPU? Option A, it stores files and folders. Option B, it executes program instructions. Option C, it connects external devices to the computer. Option D, it displays information to the user. Answer is option D, it executes program instruction. Main components of a CPU. Question 177. State two components commonly found inside the CPU and describe the purpose of each. So first component is called the ALU or arithmetic logic unit. This component performs arithmetic and logical operations. Second component is known as control unit and it manages and coordinates CPU operation. Question 179. A computer is performing a complex calculation involving both addition and logical comparison. Describe the purpose of arithmetic logic unit within the CPU during this process. So ALU is used to perform calculations like addition, binary shift, etc. It is used to perform logical operations like compare two numbers. For example, A is greater than B, and to store interim result of calculations and to store, read, write data to or from the accumulator register. Registers. Question 181. The CPU contained registers. State the purpose of a register. So the purpose of a register is to temporarily store data, instruction, or addresses. Number 2, to allow immediate access to data during fetch, decode, execute cycle. Question 182 gave three registers that are built into the CPU. So we have MAR or memory address register. We have MDR or memory data register. Then we have ACC or accumulator register. Then you have PC or program counter register. And then last we have CIR or current instruction register. Question 183, name the register that stores the address of next instruction to be fetched. So that is PC or program counter register. Question 184, a programmer is writing assembly code for a simple calculator program. The program needs to store intermediate result of calculations. Identify the component within the CPU that accumulator is built into and describe the purpose of the accumulator in this program. Accumulator register is used to store the result of interim calculations. It is part of arithmetic logic unit. Question 185, compare the role of program counter and accumulator in fetch, decode, execute cycle. So program counter stores the address of next instruction while the accumulator register stores the result of arithmetic logical operations. Program counter increments after each instruction is fetched while the accumulator register update during and after execution stage. Buses. Question 187, state the function of a bus in a computer system. So the function of bus is to transfer data, instruction, or control signal between components inside the computer. Question 188, a computer is executing a program. Identify one bus that can be found in the CPU and explain its purpose in fetch, decode, execute cycle. So we have three buses. The first one is called address bus. So address bus transmits address between components in the CPU. Second one is data bus. It transmits data between components in the CPU. And the last one is control bus. This bus transmits control signal from control unit to the other components in the CPU. Topic 18, the fetch, decode, execute cycle. Question 190. A computer program is running on a user's computer. The CPU processes instruction in a cycle that has three stages, one of which is execute stage. Identify one other stage of the cycle that is performed by the CPU. So we know there's a fetch, decode, execute cycle, and the two remaining stages are fetch and decode stage. Question 191. Complete the following statement about the fetch, decode, execute cycle. An instruction is fetched from the RAM into the CPU where it is temporarily stored in the MDR or memory data register. The instruction is then sent along data bus to the control unit or CU to be decoded. The dash will then perform. The ALU or arithmetic logic unit will then perform any calculations and logic operations that are required to execute the instruction. Question 192. So here is a diagram of fetch stage of the fetch, decode, execute cycle. You need to memorize this diagram or know how to draw it because it's usually in the exam. Topic 19, factor that can affect the performance of a CPU. Question 194, a computer CPU, central processing unit, process instruction and data, gave three factors that can affect the performance of a CPU. So we have clock speed, second one is cache size, and third one is number of cores. So these are the three factors that can affect the performance of a CPU. Clock speed. A computer central processing unit, CPU, clock speed is a key factor in its performance. State what is meant by CPU clock speed. The number of instructions a CPU can carry out per second is known as the clock speed. Explain how the clock speed of a CPU is measured. So the clock speed is measured in hertz. 1 hertz is 1 cycle per second. CPU clock speed is often measured in gigahertz. 1 gigahertz is 1 billion cycles per second. Question 198. A computer CPU clock speed is increased from 1.2 gigahertz to 2.2 gigahertz. Describe the effect this change is likely to have on the computer's performance compared to the before the change. The computer is likely to perform faster. The processor can execute more instructions per second. The computer will complete tasks in less time. Application will load and run faster. Question 199. A computer technician is explaining the specification of a new computer to a customer. The computer has a single core, 3.5 gigahertz processor and 8 KB cache. State what is meant by 3.5 gigahertz processor. So it means it can run 3.5 billion fetch, decode, execute cycle in each second, or it can execute 3.5 billion instruction per second. Question 200. A computer's CPU has a clock speed that affects its performance. Give one positive effect and one negative effect of high clock speed on the performance of a computer. Positive effect, program run faster. Negative effect, overheating. Another negative effect is more power consumption. Question 201. What does 3.2 gigahertz clock speed mean? Option A, the CPU executes 3.2 billion cycles per second. Option B, the CPU stores 3.2 billion bytes of data. Option C, the CPU has 3.2 billion cores. Option D, 3.2 billion instructions executed at once. So it means that option A is correct. The CPU can execute 3.2 billion cycles per second. CPU cores. Question 203. State what is meant by the term CPU core. It's a processing unit within the CPU that can execute instruction independently. Question 204. A library has a self-checkout system that allow customers to register books that they want to borrow. The self-checkout system has a CPU. State the purpose of a core in a CPU. So the purpose of a core in a CPU is to perform a fetch, decode, execute cycle or to execute an instruction. Question 205. Name two advantages of having multi-core processor. Number one, it allows multitasking by running multiple processes simultaneously. Number two, can improve performance for programs designed to use multiple cores. Question 206. Identify one type of task that would benefit most from a multi-core CPU. So video editing or 3D rendering, these type of tasks will benefit more from multi-core CPUs. Question 207. Describe the difference between a single core and a quad-core processor. A single core processor has only one processing unit which execute one instruction at a time. A quad-core processor has 4 cores, allowing it to process multiple instructions at the same time. CPU, cache, memory. Question 209. State the purpose of cache memory. Temporarily store frequently accessed data and instructions close to the CPU. Question 210. Name one advantage of using cache memory. It allows faster access to data than the main memory. Question 211. A graphic designer, Sarah, is working on a project that involves frequently accessing and manipulating large image files. The computer she is using has its cache memory upgraded from 32 KB to 64 KB. Explain how this increase in cache memory is likely to affect the performance of our computer. More cache improves performance because more cache means that the processor can access more frequently used data or instruction faster instead of having to access the data from the RAM. Question 212. A supermarket is upgrading its self-checkout system. The single core CPU is replaced with a CPU that has 4 cores. Explain the effect this has on the performance of the self-checkout system. It may increase the performance because more instruction can be processed simultaneously. Question 213. Identify where cache memory is usually located in a computer system. So it's usually located on or very close to the CPU, for example, inside the CPU chip. Question 214. The student wants to replace the CPU to increase the performance of the computer. Explain why a different CPU can increase the performance. Number one, it could have more cores, increasing the number of fetch, decode, execute cycle it can perform at the same time. Number two, it could have a higher clock speed, increasing the number of fetch, decode, execute cycle per second it can perform. And number three, it could have a great cache size, meaning more frequently used data can be accessed faster.